Okay, so this is one question. So here the question is, find the transfer function x2 of s by f of s. So the question is to find x2 by f. So let me give you a clear idea. Here see, m1 means it is called mass of the body. Mass of the body means, let me say it is my body, okay, my body, a human body, so which is called as mass. So m1 m2 are called as mass of the bodies. Then I will wear some clothes, right? So to cover my body, the clothes are must for me. Those are called as dampers. So dampers are represented as D1, D2 like that. So here if you see K1, D1, M1, K2, M2 are there. It means we have only one damper. So done. Then I will wear some ornaments to make myself beautiful, like watches, bangles, earrings, hand rings, so whatever it is. So those are called as springs of the body. So what are the springs here? K1. Okay, K represents spring, D represents dampers. Sometimes D will be represented as F also. Okay, so D represents dampers, M represents mass, K represents the spring of the body. So springs, how many spring Ks are there? K1, K2, that's it. So K1, K2 are the springs in this question. M1, M2 are the mass of the bodies. D1 is the damper. Then what else are there? K1 is done, D1 is done, M1 is done, K2 is done, M2 is done, F. Okay, what is F here? F is force of the body. F is the force of the body. So which is called as input, means you're forcing me. The input to make me move, the input to my body is force. When you give a force to me, means when you push me, a force is given to me. Automatically what happens? I might be in one position, now I will move to another position, right? So that is called as displacement. What is it? Displacement, and it is represented as x. So when you forced me, I was moved, means I was displaced. So the displacements are x1 and x2 here. If you see here, x1, x2. So it means there are two persons. These two persons were given force. So their positions were moved. M1 moved to x1, M2 moved to x2. So that is the displacement. That is the distance or something, whatever it is. So there is a movement in the body. So M1 is a human. This human is having K1 spring, K2 spring, D1 damper with a displacement x1. That is the mean. What is it? M1, okay, mass of the body. This is a human being. Okay, this human being is having, from, let us start from left. He is having spring K1. Okay, he is having K1. Then he is having D1 damper. So spring is represented as this inductance symbol. Damper is represented like this. Okay, so damper means D1. Okay, D1 is also connected to this body, means this mass is having D1 dress, K1 ornament and K2 ornament also. But K2 is, this ornament is connected to human being 2 also. So that's why I am writing it here. What is it? K2. So K2 is connected to second person also. So K1 is connected, D1 is connected, K2 is connected. Then anything else around M1? Nothing. 1, 2, 3. So 1, 2, 3 are done. Then go to second person. In the second person, only K2 is there, force is there. So there is a force. So K2 is connected to both. K1 is connected only to M1, D1 is connected only to M1. Now, okay, dresses are done. So there is no dress for this human being. He is having only one ornament. This human being is having two ornaments with a dress. Done. Now, displacement. Why are we using displacement? Saying that someone has forced M2, then there is a movement, right? So what happens? So you pushed M2, then automatically M2 has moved, and that movement is called as x2 displacement. So what I will do is mass. When I talk about mass, I will say as the force applied on my body. So you applied a force on my body. So I moved. How much I will move? Double derivative is my movement, x. Double time, right? So double derivative of the displacement. So you pushed me. So some force has acted on me. So I moved a displacement. So my body displacement is d square x by dt square plus. My damper means my dress displacement is single derivative. Because when you force me, I will feel more force. My dress feel less force. And my ornaments feel very less force. Is it clear? So when you pushed me moving, my dress moving, my ornaments moving, my body is experiencing more d square x by dt square, my dress is experiencing less dx by dt, and my ornaments are experiencing very less force, kx. So now let us choose any one of the mass. So let us go for first mass. The first mass is m1. Okay, m1. Is there any force here? K1, D1, K2. So there is no force for M1. Obviously what I will write? 0 is equal. So there is no force on mass 1. But because of the force on M2, connection between the ornament, it made M1 also do a displacement. That is the mean. Okay. So there is no force on M1. Perfect. Then M1 is M1. X is what? For M, what is the X? X1. So what is it? X1. So I will write it as d square x1 by dt square. Damper is d1. So d1 dx1 by dt. K is k1 x1. So k1 I will write it as k1 x1. d1 I will write it as d1 dx1 by dt. m1 I will write it as m1 d square x1 by dt square. 1 done. 2 done. 3 k2 is there. So plus K2. K2 is experiencing X1. So X1. But remember, K2 is in connection with M1 and M2. So I will write it as X1 minus X2. So what is my first equation? Force is 0. So M1 d square x1 by dt square plus d1 dx1 by dt plus k1 x1 plus k2 into x1 minus x2. Mass is there, so it has a displacement. Damper is there, it has a displacement. Spring is there, it has a displacement. Spring 2 is there, it has a displacement. As I am talking about M1 mainly, I am writing it as x1 minus x2. Okay. Now, this is M1 equation. Now, what is M2 equation? Again, force is equals to m d square x by dt square. M2, is it having force? Yes, it is there. So F will be F only. M will be M2. X2 is the displacement. So equation will be d square x2 by dt square plus damper. Is there any damper here? We have only 2, force and K2. So we don't have damper. So this one won't come. Then we have only K2. So K2 is there. K2 is x2. But K2 is in combination with x1 also. So I will write it as x2 minus x1. So you should see both the differences. Here x2 minus x1. Reason is I am talking about M2. Here x1 minus x2 because I am talking about M1. So this is my first equation. This is my second equation. Because of these rules, I got this equation. So according to this, what is the rule? F is equals to mass plus damper plus spring. F is equals to mass d square x by dt square plus damper dx by dt plus spring kx. So these things you should remember. And you should see how the picture is modified and you should write the equations. Okay. So this is your equation 1 and this is your equation 2. So this is how you write. Okay. So in exam, this is your question. So to this question, how you should start writing the answer? Answer is, okay, what is our picture? M1 is there. So to M1 what is connected? To M1, K1 is connected, which we can call as K1x1. D1 is connected, we are calling it as D1 dx1 by dt. Then K2 is connected, which we are calling it as K2 into x1 minus x2, because we are talking about M1. Then we have M2. M2 is being a force. So from the given question, this is the picture you are bringing out. Then you are saying M1 equation. So the differential equation is F is equals to M plus D plus K. Remember this equation all the time. So F in M1, do you have any F? No force. M is called M1. So M1 should be written as d square x by dt square, but here x is x1 plus damper. Is there any damper? Yes, damper is there. So d1 dx1 by dt plus K. Is there any spring? Yes, two springs are there. One spring is single connected, another spring is double connected. So we are writing it as x1 minus x2. So try to solve this. You should solve this in such a way that you should remember the question is asking about x2 by f. The question is about what? x2 by f. They said find the transfer function x2 by f. So we have force as the variable input. x1 is the displacement of first mass, x2 is the displacement of second mass. So these are the three variables we are preferring for. In that three variables, the question is about x2 by f. It means they are not concentrating on x1. So you should eliminate x1 from your equations. So the first equation is about x1. So let us try to eliminate it. How can we eliminate? Let us see. Okay. Now see. So m1 d square x1 by dt square plus d1 x dx1 by dt plus k1 x1 plus k2 into x1 minus x2. So this is the equation. Perfect, right? Now this equation I am saying up. Let me just divide this x1 minus x2. So let me write left equation to right, right equation to left. So equal to 0 is that set, which makes our job easy. Okay. So I am writing it as m1 d square x1 by dt square plus d1 dx1 by dt plus k1 x1 plus k2 into x2. Sorry, k2 into x1. So k2 x1 minus k2 into x2. k2 x2 is equals to 0. Now I am saying apply Laplace transform. So if you apply Laplace transform, what happens? What is Laplace transform saying? According to Laplace transform, d square x by dt square is written as d square, double derivative. So Laplace transform s square. X will become capital X of s. Similarly, dx by dt, single derivative d by dt. So single s will come, small x will become capital X of s. Similarly, x, small x will become capital X of s. So this is Laplace transformation. So according to that, I am going to apply this here. So when I apply Laplace transform, m is the coefficient. So mass will be mass only, my body will be my body only, right? So I will write it as m1. Then d square x1 by dt square will become d square by dt square will become s square. Small x will become capital X of s. Small x1 will become capital X1 of s. Are we clear about this? m1 became m1 because it's the coefficient. D square by dt square will become s square. Small x1 will become capital X1 of s plus d1 is the coefficient. My dress will be my dress only. Then dx1 by dt will be s into x1 of s plus k1 x1 will become k1 capital X1 of s plus k2 x1 will become k2 x1 of s minus k2 x2 of s, which is equals to 0. So in this, if you see x1, 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 x1. So let me take x1 of s as common. So x1 of s, m1 s square plus x1 of s, d1s plus x1 of s, k1 plus k2. I wrote everything. Now the remaining is x2, k2 x2 of s. Let me send it to the right hand side because it is already equal to 0. So I am saying it as negative will go that side, will become positive. So x2, k2 x2 of s, k2 x2 of s. My importance is to eliminate x1. So I want someone for x1. So I will say x1 of s is equals to, so this multiplier I will send it this side. It will become divider, right? So it will become k2, k2 is there, by this multiplier I am sending it as a denominator. m1s square plus d1s plus k1 plus k2 x2 of s. So now I said x1 is equals to something into x2. So with my first equation, this is what I did. So from my first equation, this is my first equation, right? This is my picture. From my first equation, I tried to eliminate x1. So I got something for x1. Now, let me go to my second equation. What is my second equation? m2 is having k2 and f. That's it, right? k2, m2, f. That's it. So remember that. So now my equation again is for m2, the differential equation is again f is equals to m plus d plus k. For m2 we have f, yes we have f, which is f of t. M is nothing but m2, displacement is d square x2 by dt square plus d. There is no d for mass 2, right? For mass 2 we have no d, so there is no d, and we have k. So what I will do, I don't write d, I will write k. K is k2, but k2 is in combination with both, so x2 minus x1, because I am talking about m2, so I should prefer x2. Okay, so I should prefer x2. Now this is my equation. Now let me separate this. So I will write it as f of t is equals to m2 d square x2 by dt square plus, okay, plus k2 x2 minus k2 x1. I multiplied k2 with these two. Okay, so now this is my equation. Now let me apply Laplace transform. Okay, so what is our next step? Apply, same like previous equation we are doing, apply Laplace transform. So according to Laplace transform, what happens? F is a variable, so f will be f only, but we are applying transformation, so time will become yes, right? That's what you learned in Laplace transformations. So f of t will become capital F of s, which is equals to m2 will be m2, d square x2 by dt square will be s square, small x2 will be capital x2 of s, less k2 will be k2, small x2 will be capital x2 of s, minus k2 will be k2, small x1 will be capital x1 of s. Right? So now f of s is equals to x2 common, x2 common. Let me take x2 as common. So x2 of s into m2 s square plus, so m2 s square plus k2 minus k2 x1 of s. I don't want x1 of s, right? Because my requirement is what? x2 by f. So I want to eliminate x1. So that's the reason in previous equation I got something for x1. So let me write this equation there. So what is this equation? k2 by m1 s square plus d1s. So let me write it there. So I'll write it as k2 by m1 s square plus d1s plus k1 plus k2 into x2 of s. So this is equals to x2 of s into m2 s square plus k2 minus k2 into k2, k2 square by m1 s square plus d1s plus k1 plus k2 into x2 of s. x2 of s, x2 of s. Overall I am taking x2 of s as common. Then what will be my equation? m2 s square plus k2 minus k2 square by m1 s square plus d1s plus k1 plus k2 f of s. So if you remember, when I am talking about poles and zeros, I said the equation should be always numerator by denominator. So this is like a minus b by c. So let me take an LCM for this. So this is equals to x2 of s into, if I take LCM, m1 s square plus d1s plus k1 plus k2. So this will be multiplying to this because there is no LCM here. So m1 s square plus d1s plus k1 plus k2 into m2 s square plus k2 minus k2 square will be k2 square, which is equals to f of s. So now this is the equation. Now our requirement is what? x2 by f. So f should go this way. So x2 by f. Then obviously what happens? A by b will go this side as b by a, right? So let me say, let me call this as a, let me call this as b, let me call this whole thing as c, let me call this whole thing as d. So now the equation is in the form of a is equals to b into c by d. My requirement is b by a. B by a. So b by a is equals to what happens? D will go that side. So it will become d by c. Isn't it? A is equals to b into c by d. Then what happens? A is equals to bc by d. D will go that side. It implies dA is equals to bc. I want is a by b. So I will, I want is b by a. So I will say d by c is equals to b by a. That is what I wrote. Okay. So according to this, what happens? x2 by f is equals to this by this, right? So finally, I am concluding the answer as x2 of s by f of s is equals to m1 s square plus d1 s plus k1 plus k2 by m1s square plus d1s plus k1 plus k2 into m2s square plus k2 minus k2 square. If you want to stop it here, stop it. Okay, this is a 20 marks question. If you stop it here, you will get 19 marks. You will lose 1 mark. If you don't want to lose that mark, you can just multiply these two like this. So numerator will be numerator, no change in the numerator. Then denominator will be multiply. m1 s square into m2 s square. It will be m1 m2 s power 4. Okay, this is done. Then m1 s square into k2 plus m1 s square k2. So this is done. Now d1s into these two. d1s into m2 s square will be m2 d1 s cube plus d1s into k2. d1s k2 plus k1 into m2 s square. m2 s square k1 plus k1 into k2 plus k2 into m2 s square. So k2 m2 s square plus k2 into k2 square minus k2 square. k2 square cancel. So therefore I can say x2 of s by f of s is equals to m1 s square plus d1 s plus k1 plus k2 by, check s power 4. Where is s power 4? It is here, because highest is 4, 2, 3, 2, 0, 2. So highest is 4. So first we should write s power 4 into m1 m2 plus s cube into s power 4 is done. S cube is this. Is there any s cube here? There is no s cube. So it will be m2 d1 plus s square into, where is s square? Here is s square, m1 k2, because I took s square out. So m1 k2. Then where is s square? Here, m2 k1 plus m2 k1, and then here is m2 k2 plus m2 k2 plus s power 4 is done, s cube is done, s square is done, s power 1. So s power 1 into, where is s power 1? S power 1 is here, d1 s k2. So s already I wrote, so d1 k2. So this is also done. Is there any s here? No s. Plus s power 0 is k1 k2. So this is your answer. If you want to write it nicely, you can again write x2 of s by f of s is equals to m1 s square plus d1 s plus k1 plus k2 by s power 4 into m1 m2 plus s cube into m2 d1 plus s square into m1 k2 plus m2 k1 plus m2 k2 plus s into d1 k2 plus k1 k2. This is your final answer. So this gives you 20 marks. So you are not supposed to write this in the exam. I just gave it for the explanation purpose. So in the exam, my question will be like this. This is my question. Then you should draw this picture, explain it, get something for x1. m2, substitute x1. So you want is x2 by f. Focus on the equation x2 by f. So x2 by f wrote. If you want to stop it here, stop it. For this you lose 1. If you want that 1 mark also, just derive it. I repeated these two, so actually only 2 steps are there. So that is how. This is the first question. Practice, practice, practice. If you practice more, you will know the equations very clear, right? Sha.